So when it comes to buffering, let's try to understand each of this needs to be buffered. How and what? Let's try to understand further. When it comes to buffering, both of the devices, rather both of the types needs buffering. Why buffering is needed? Okay, let's understand. We have some IO device. That IO device would give us some information which a CPU or a process will process via or with the help of CPU. Let's consider that there is no buffer. In this case, the speed of IO device in reading or writing, that is, whether to give data or to take data, should be parallel to the processor's speed of reading and writing. This is not generally possible because the processor is extremely fast compared to the IO device. In some cases, IO device could be very slow compared to the processor and the process speed. As an end result, if there is no sync between process and IO device, end of the day, communication will not be possible. Another common thing used buffering for is when you do buffer, we keep data ready so that the process and the processor, which is extremely fast, will not be waiting for getting data and performing certain action. There are three major ways of performing buffering. The first one out of that is called single buffering. Single buffering is a simple step in which data will be first filled in the buffer, and once filled, data will be read by passing it to the process. So data comes from the IO, goes in the buffer. Once buffer is filled, it goes to user process. This technique is fairly simple but does create a technical problem called wait and forward. What this means? Now consider a device is extremely fast and the process is slow. After passing every data to buffer, device has to wait till process reads that data so that the buffer can be empty and then rewrite again. The reverse of this, if the process IO is by default slow and the process is extremely fast. Even under this case, when process reads the data and empties the buffer, it needs to still wait for the next set of data to be read from the IO and transferred to the buffer. One of the solution for this condition is double buffering. In double buffering, we have slight different change. That change is simple. Instead of using a single buffer, as you can see, we use two buffers, 1 and 2. Concept is very simple. One buffer is currently being filled by the system. When this buffer is getting filled, other already filled buffer is getting consumed by the process. So both of them would work in a zigzag manner in filling. When IO device fills one, other which is already filled will be used by the process. This double buffering uses two buffer, which does create a big advantage of speed. But again, the system has a downfall that if IO device is extremely fast and if two buffers are filled, under that scenario, the system will not be able to handle. Solution to this can be found with the next technique called as circular buffering, also known as end buffering. Now what exactly end buffering is about? Well, simple. Instead of using one or two buffers, we will use n buffer. As seen from the diagram, these buffers are arranged and used in a round robin fashion. That means one will start from first. When first is filled, it will reach to the second and it will continue till n and again go back. That means the sequence, consider we have 5 buffer. We would start filling buffer 1, then second, then third, then fourth, fifth. Consider when the process is filling buffer 3, 4 and 5, already OS has consumed 1 and 2. In this time, after this, again the filling will start from 1, 2, 3, 4, 5 and so on. So working with N buffering does provide an advantage of a high burst data being copied to buffers which can be used later on by the process, providing a very high data transfer speed. That's it guys. This is for buffering. As we said, there are three techniques to work with. A quick recap to that. Block and stream cipher. Without buffering, synchronization is an issue. We started with single buffering, but wait and forward, it is extremely slow. We started with two buffer, a good idea, but high burst of data cannot be handled. So they finally created N buffer technique where N buffers would be filled rapidly. Thanks for watching the video.